Okay, so good news. When we look at BMI here, you can see that it's in the right range and looks like it's approximately where it should be. And here's even somebody who stays very much the same from wave 1 to wave 3. A lot of other folks are changing, but I know I did my calculations correctly. So what I need to do now then is do the dependent samples t-test. I'm going to compare means. And this time, here it's called, in SPSS, it's called a paired samples t-test, but it's the exact same thing as we've been learning in class, how to do a dependent or paired samples t-test. Click that here. And this one looks a little bit different than what you've seen for the independent samples t-test. What you're going to do is you're going to create a pair of variables by identifying variable 1 and variable 2. This one's easy to find because they're both down here at the bottom. So I have BMI at wave 1, I'll put that in there, and that'll go in as variable 1. And then BMI at wave 3, and that's variable 2. I'll hit paste, come over here to the syntax window, run that, and what you get here, the first table again is your descriptive information. Okay, we're not going to look at this right now, we'll think about correlations later in the semester, but the table that we're going to focus on is these results of the paired samples t-test. And so what you see here is that you get some of the just descriptive information over here on the left, and what we're looking for are these 3 cells out here to the right where we're given our t-value, our degrees of freedom, and our significance. So these other variables over here, this is the mean difference, which you guys have known how to calculate by hand. That's the standard deviation for the difference scores, that's the standard error, and then this is the t-value, and the degrees of freedom and the significance. Okay, so we can transfer that information. Oh, it's a little hard to see now because that's sort of scooched over. Let me pull the table back up so we can see both at once. And let me write out this sentence and I'll be right back. So here's the sentence that I wrote. I should have elaborated on this a little bit more just to make sure you guys are still comfortable with this. So the significance, we're comparing it to the alpha of 0.05. It's 0.000, so it's dramatically less than 0.05. Again, that makes sense given the huge size of this t-test. One other thing that I should have mentioned earlier is that whether the t is positive or negative doesn't make any difference. It's really only the magnitude we're interested in. That's because we're running all of these as two-tailed tests, and the sign of this t-test is just dependent upon which variable you entered as variable 1 and which you entered as variable 2. So if I had reversed the way I entered these, this would have come out to be a positive number. And since it's non-directional, it doesn't make any difference. It's just the magnitude that matters. So the sentence here, there is a significant difference in BMI from wave 1, and then I get the means. This is over here in the descriptive part, and the standard deviation. To wave 3, same thing, get the mean and standard deviation here. And then I put in the information from these green boxes. T with 4,602 degrees of freedom is negative 60.07, p is less than 0.001, and then because it's significant, just some sort of an interpretation. Clearly it means that children's BMI is increasing over this period of time. Okay, that's it. Great job. We're done with the in-class portion. So once you feel like you've mastered all of this, then you're welcome to start the out-of-class portion, and that, of course, is the part that you'll be turning in for the assignment. All right, have a good day.